Okay, so this is our week 1 review video. I just feel a little awkward making videos, so I apologize if I'm like stumbling or things get a little weird in terms of like the way I'm wording stuff. It's just the nerves coming through. So we started out at the beginning of the week, Monday and kind of Tuesday, going over some review and stuff from Algebra I that we learned. Those are our solvings and function notation, stuff like that. So just a quick overview of solving. Remember, we're following PEMDAS, that's parentheses, exponents, multiplication, division, adding, and subtracting. And they're always typically with their inverse operations. Remember, that's just the operation that we use to undo it. So in an equation, if I see multiplication, well, that means I need to do my inverse operation of division because that will help me get rid of it. So these two here are inverse operations. One undoes the other. So that means when you're solving, make sure you're saying, okay, what do I see? What type of operation? And then, okay, how can I get rid of that? Well, if I see multiplication, inverse operation is division, so I will divide. Same thing with our adding and subtracting. They're opposites of each other. For the most part, parentheses and exponents, we don't really deal with those too much yet. The only thing we deal with our parentheses is, okay, I want to get rid of those. And the way I get rid of those is usually our distribution step. So, kind of the thought process I go through when I'm solving. So, this is just like a thought process here. Thought process. So I'm like, okay, what am I isolating? I wrote this so wrong. Did I? No, what am I isolating? There's just should be a larger space here. That's not one word. What am I isolating? So identify your variable basically is what this is saying. Identify variable. Now we say, okay, what do I get rid of? So what is outside of that variable? Next is how do I get rid of it? So that's inverse operation. So remember, that's just identifying operation, and then what is its opposite? So if I'm doing this with actual solving, what I'm going to do is I'm going to say, okay, let's say I have the equation, I have a 2x plus 3 is equal to 5. Well, what I want to isolate, that's question 1. What am I isolating? If I'm solving, I typically want to isolate my variable. So x here is what I'm isolating. So next it says, so this was for question 1. Question 2 says, well, what do I get rid of? Well, for that second question, I need to get rid of this 2 and this 3. As for the how do I get rid of it, we need to look at our PEMDAS. We're going to say, okay, I need to go from the bottom up when we're solving, unless I see that distribution. So distribution, and then we deal with adding, subtracting, then we deal with multiplication. So 1, and then 2, and then 3. That's the order we'll do those ones in. So I see addition and subtraction here. I have a plus 3. So if I see addition, I put adding and subtracting, but addition, its opposite is subtraction, so I need to subtract on both sides of my equation now. If it helps you to draw the line, I recommend drawing that in. So I'm subtracting 3 from both sides here. It will cancel that out. Next, I have the 2x then left on this side, and then on this side, I have 2. So remember, we're still saying, okay, first, what am I isolating? I'm still isolating x. What do I need to get rid of? I still need to get rid of 2. Now, how do I do that? Well, what operation do I see here? This is 2 times x. Remember, times, that's the same as multiplication. So to get rid of multiplication, I have to do division. So divide by 2 on both sides. 2's will cancel over here. Final answer will be an x is equal to 1. Remember, on your test, you don't want to box, but just to make it clear what my final answers are, I'm going to be boxing them in the videos and on the notes, I think, from here on out, because it's been confusing some people. What we're going to do next, we're going to talk about that function composition a little bit. So it's saying, hey, f of g of x, all it's saying is replace x with a function. So normally the way we see functions is f of x, that's our function notation. What we've done is we've replaced this x here with g of x, which is how we got to the f of g of x. So if I have these two functions down below and I say, hey, find f of g of x, all it's saying is replace x variables with my g of x function that I see over here. So the way I think about this is I say, okay, f of x, this is my outer function. I'm going to write this but at x, replace with g of x. Sorry, I know the camera is being a little shaky. I don't normally do these at this desk. It's a little wobbly, so I apologize for that. So what that's going to look like is if I do this f of g of x, we're saying I have f, and I'm going to do g of x in green here. G of x. So that's saying, okay, well I have f of, well my g of x function is a 1/2 x minus 3. So now my f function is a 2x plus 1, so I have 2, and normally I have x, but we're just saying evaluate this at g of x. So normally if I was plugging just a regular number and I say, hey, well what is f of 2? I would have that 2x plus 1, so I'd pull 2 times, well I'm plugging a 2 in for x, so 2 times 2 plus 1, that would get me f5 because 4 plus 1. Well this time instead of plugging in 2, I'm plugging in that function here. So it's 2 times the 1/2 x minus 3. Now I have my plus 1, because I should still have this full function, 2x plus 1, but I've replaced x here with g of x. So g of x replaced x. So a common mistake I was seeing in class is that people were still writing an x out front here. Make sure you don't do that. I've completely gotten rid of my x. I took it out and I replaced it with g of x. So replace means this x is no longer there. My g of x is there. From here you're simplifying, so you're going to multiply that 2 through. So that's going to look like an x minus 6 plus 1. Combine your like terms. Be really careful here. I saw a few people in class this week trying to combine variables and constants. If one has a variable and one does not, I cannot put them together. So my x stays separate, and a negative 6 plus 1 is a negative 5. If you're still having struggles with this function composition, we will talk about it in tutorials on Tuesday, and I'll post some Khan Academy links for you guys to do some extra practice if you think you need that. Next thing we did was our notations. So we learned 3 different notations. We learned roster, set builder, and interval notation. So roster, this is just when I have like a list of numbers. So we put our brace, our list of numbers, and brace. So say we wanted 1, 2, and 3, we would just say 1, 2, and 3. Our set builder works a lot better for things where we have inequalities and things like that, or we need to describe something with some words, because we can't use those in our roster notation. This is much more convenient for small sets of numbers, small sets of numbers. And you are always welcome to replace numbers with that hashtag sign or pound symbol. It's just shorthand. I'll know what you mean. Pretty much everyone else should know what you mean. Numbers. Set builder, like I said, those are those inequalities. This is for when we don't have a finite number of numbers in our set. So like I can't use roster notation to represent the inequality x is less than 2. I can either do set builder or I could do interval for that though. So x is less than 2. If I want interval notation, I put that brace x bar in the front. Remember, this is just a line or a bar. It's not an L, an I, or anything like that. It's just a space, basically breaking up that x variable and what it's defined as. And then we can throw an end brace on the end. So this is technically how we would represent domains more properly instead of using just an inequality. And an inequality by itself is helpful, but it's not technically proper notation. The last one was that interval notation. So remember, parentheses does not include the value, does not include. Brackets, that's our or equal to. I can also have a mix of both. And one part we looked at was that unbounded when it goes to infinity. So infinity always goes with parentheses. Yeah, so if I were to write that x is less than 2 in interval notation, remember it's our smallest, then our largest. So it's either a parenthesis or a bracket, smallest, comma, largest, and then parenthesis or bracket. So in this case, if x is always less than 2, that means I can do any number going all the way into my negatives as far to the left as I can think on a number line. So my smallest number is a negative infinity in that case. And remember, negative infinities, I said, always have to go with parentheses. Parenthesis will go here, comma, our largest number. Well, the largest I can get to is a 2. But because there's no or equal to here, I would have to use a parenthesis here as well. Say I had something like x is less than or equal to 5. It would look very similar. Once again, it was less than, so we start at negative infinity, comma, 5, and this time we could use that bracket. So whenever you see a less than or a less than or equal to, that's going to go with a negative infinity. But if you see a greater than or equal to, that's always going to go with a positive infinity. So we have two examples over here. Example A says, hey, we're starting at negative 2 and it's going on forever. I find interval notation a bit easier to do if I can think about that number line. So if you can't think about that in your head, always feel free to write that out here. So we're saying, okay, my smallest number is a negative 2 and it goes all the way up and I see an arrow. Remember, arrows are saying, hey, it goes to infinity. It's on the right side. That's a positive infinity. So here our interval notation would be, okay, negative 2 comma positive infinity, parenthesis in parenthesis, because this open hole, remember this is just saying, okay, x then is greater than negative 2. Greater than goes with positive infinity, and if there's no or equal to, it goes with the parentheses. For the next one here, oh, I forgot to draw the line in between. This has a line in between, sorry, connecting them, I forgot to draw it in. So we're gonna say, okay, well, my smallest number is 3. How far to the right can I go? Well, I get stuck at 10. That's how far I can go to the right. So I'll have a 3 comma 10. But this is an open hole, parenthesis, closed hole, bracket. We use these a lot going forward to represent our domain and ranges. So you want to make sure you're really familiar what this represents, because domain and range is kind of a tricky concept to conceptualize in your head. And so if you can make sure you're not getting stuck on this, it's going to make it a lot easier to get mastery on that next part when we go into domain and range. If you want to know what this looks like in set builder, I already wrote one of my inequalities here. Remember, to get from interval to set builder, you want to say, what is my inequality? Well, now I just put my structure around it. Brace x bar, x is greater than negative 2, end brace. In this case, x, it's in between that 3 and 10, but it's or equal to over here, so I need that bar. Once again, now I just put my set builder notation around it. 3 is less than x, which is less than or equal to 10. We will more often use this interval notation. I didn't really use set builder commonly until I took linear algebra in college. Because that was just how my teacher taught. He preferred set builder, but I typically will be doing this in interval notation. If you're ever like, Miss, I just really hate interval notation, let me know and I'll make sure I start writing both of them for you guys if you do prefer this inequality form. After that, linear functions. So linear functions, they were familiar to most of you from Algebra I, which is good, but we still struggle a little bit with like determining which equations we should be using. So I'm just going to do a quick review of each of those equations here. So remember, we had our slope-intercept. Slope-intercept. So I would pause here, try and write the slope-intercept equation. Just take like 30 seconds to think about it, write it down, because trying to activate that in your memory and write it down is going to be more helpful than just copying it from me. So you should have y equals mx plus b. Now the key thing to remember here is that this m, that's your slope. There's a couple ways to think about slope. That's your rise over run if you have your graph, rise over run. You can also find it from 2 points using our slope equation. M is equal to y2 minus y1. Wrote those y's differently. And then x2 minus x1 if you have like a table of values or if they give you 2 points. So this can come from a table or if they give you some points. B here, that is just your y-intercept. So that's your y-intercept. So what that looks like is 0, comma, some number here. And that number could be any real number. So it could be 1, it could be -10, it could be 1/3, any number you can think of, as long as it's saying, hey, your x value was 0. The next one we talked about was that point slope form. This is one that's a little bit trickier to remember, so point slope. So once again, pause, try writing that down from memory before you copy it from me. So it should look like your y variable minus the y value of your point is equal to m times your x variable minus an x value from your point. If you prefer, you can write it with that y1 on the other side. So y is equal to the slope times your x variable minus x1 and then plus y1 on the outside. Sorry, here. This form, I don't know why I don't like it as much, because it's easier for me to be like, oh, y minus y and x minus x. But if you prefer this form, they're equivalent, they're the same thing. So that's what 3 lines mean, it means equivalent. Since they're not necessarily equal, because y is not equal to y minus y1, but these equations are equivalent to each other. So once again, this is just our slope here with the m. Same notes we did up here apply. After that, this y1 and x1, those are actual numbers because it comes from some point. Same thing over here, those are x1, y1, these are numbers that come from a point. We will always have an x and y left behind because that is how we write an equation for a line. So these ones that I'm highlighting in orange here will always stay behind. When we're writing a linear function, we always have to have an x and y left over. The only other equation we talked about was this slope equation here. So if you want me to write it bigger, I'll write that here for you. M is equal to y2 minus y1 over x2 minus x1. If you're like, I don't like that the 2 is in the front and the 1 is in the back, that's fine. You can switch them around. They're equal to each other actually. So if you also do y1 minus y2 over x1 minus x2, those are the exact same thing. If you want to know more of why, I can show it to you individually, but I don't want to show it to you and just have it be like, what, and confuse you. But if you're that person who's like, I have to have justification, just come see me, I will show you why. I think that's pretty much it for our linear functions. I'm going to do a quick example for each on the other side, but that's all of the actual notes that we needed. So if you're like, Miss, I've got this, I don't need an example, you're free to stop here. So an example would be, say they told me, hey, you have a slope of 3, and you also have the point 0, 5. Well, when you see 0, 5, remember, that's telling you your y-intercept. Your y-intercept is when your graph has an x value of 0 and the number it goes through. So this is telling me that my b value is 5. So whenever I see a slope and an intercept, I need to think slope-intercept form. Intercept, I tried to skip the r there. So y equals mx plus b here. Well, I already know my m value. It's going to be a 3. I'm going to replace this with 3. And I know my b value here, it's 5. So this is going to get replaced. But remember, I want a y and an x left over. So those are the only thing that I didn't highlight. They're not going to change. So y is equal to a 3x plus 5. That is all you have to do for slope-intercept. Don't overthink those ones. What can be a little bit trickier is those point-slope forms. So for point-slope, they may give you a table of values. They may be like, hey, you have x, you have your y. This is more common for word problems. And they'll be like, oh, you have the point 10, 20, and you have the point 20 and 5. And you have the point 25. I'm not going to do a third point because I can't match that off the top of my head. But it doesn't matter how many points you have, you just need the first 2. Because if I have 2 points, I can find a slope. So 2 points can give me a slope. And now I have a slope and a point. Then I can use my point-slope form. So for this one, slope, whenever I have 2 points, y2 minus y1 over x2 minus x1. In this case, I can pick either order. So if I'm going to start with the 20, my other y value is a 5. Then I need to make sure I'm starting with 10 as well, because these have to stay together. For technically, this is 0.2 and this is 0.1. So this is then on the bottom going to be a 10 minus 20. So on the top we'll have 15, and on the bottom we will have a negative 10. So if I simplify this, those can both be divided by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. Don't forget to carry your negative over though. The negative can also come up front, it can go with the 3. It can kind of float around since it's all multiplication here. I'm sorry, this keeps shaking. It must be really annoying, I apologize. But now I have a slope. Slope, that's in green. And I have a point. You could use either point, you'll get to the same place. I just usually use my top point here. So remember, when I have a point and I have a slope, I use my point-slope form. Y minus y1 is equal to an m times an x minus x1. So I'm going to replace my m, and I'm going to replace that y1 and that x1. So y minus my y value that I had, 20, is equal to m, 3 over negative 2, 3 over negative 2, times x minus my x value for that point, 10. Now I'm going to distribute here. Y minus 20 is equal to a negative 3/2 x plus, because those negatives will cancel each other out. Make sure you're being very careful with those. That's a common mistake I've seen all week. We really need to make sure we're nipping that in the butt, being really careful with our negatives. 10 divided by 2 is 5, so what this is really saying is saying, hey, what's 3 times 5? So 3 times 5 is going to be 15. Now, if you need to see that written out, that's because it's saying, hey, what's 3 times 10 times a 1/2? If I break this fraction up into its 2 parts. So then it's the same as a 30 divided by 2, which should still get me to 15. This is a little offshoot of what that distribution step was doing here. Last thing, we always want to isolate our y variable. So we're going to add that 20 to both sides. So y is equal to then a negative 3/2 x plus 35. That would be our final answer for this one. If you are still struggling with any of this, I'm going to try and post con links throughout this week. I'm a little behind this weekend because I was getting stuff fixed for calculus. But we'll also be able to do some of this in tutorials on Tuesday, like I said earlier. So if you have questions, make sure you're coming in prepped and ready to go. I will also have material for us to do. So we need to make sure if you have questions, you come in ready to get them answered. Other than that, I hope you guys had a really good weekend, and I'm sorry you had to watch math videos over the weekend if that's what you're doing right now. Yeah, I will see you guys Monday.